We are going to start off Chapter 7 with Section 1, which is about hypothesis testing. So we first want to know what a hypothesis test is. It's a process that uses sample statistics in order to test a claim about the value of a population parameter. So a hypothesis test is a process in which we use sample statistics, so we don't have to have the entire population, in order to test a claim that is made about a population. Remember that we call values that come from the population parameters and values that come from the sample statistics. So in hypothesis testing, we're going to use sample statistics to test claims about population parameters. Here's an example. Let's say that a manufacturer advertises that a car gets an average fuel mileage of 50 miles per gallon, but you suspect that it's not 50 miles per gallon. Well, what is it? It is this 50 miles per gallon. So the manufacturer is claiming that a car gets average fuel mileage of 50 miles per gallon. So what they're talking about is mu. They're talking about the population mean. So we can't really go out and test all of the vehicles. That's not reasonable. So since we suspect that it's not 50 miles per gallon, we're going to randomly sample 30 cars. Now, why did we choose the number 30? Remember that in order to use the standard normal distribution, our sample size has to be greater than or equal to 30, or the population has to be normally distributed, which we're not told, so we're just going to pick a sample of 30. So, since we can't test all cars, we randomly sample 30 cars, and when we do that, we find that the sample mean, x bar, is 47, and the sample standard deviation, which is S, is 5.5. So we have some sample data, and we're going to use that to make a prediction about the population. Now, just because we found that the sample mean is 47, does that mean that the manufacturer is wrong? Or is that not really significant? Well, in order to decide, what we're going to do is assume that the ad is correct, and then we're going to run a test. So to decide, we assume the ad is correct. So what that's saying, in other words, is that mu equals 50. Now, we don't know the population standard deviation, so we're going to use our test that we used when we didn't know the when we didn't know the population standard deviation. So we're going to use the, the one for S equals. So our standard error is going to be S divided by square root of N. So what we're going to have is a normal distribution a normal distribution of sample means with mu equal to 50 and sigma equal to 5.5. So that's going to give us the standard normal distribution. With a standard error of 5.5 divided by the square root of 30, which was our sample size. So our standard error actually comes out to equal 1. So if I draw a normal distribution where my mean is 50 and my standard error is 1, then if I move one standard deviation away from my mean, I am at 51. If I move 2, I'm at 52. And if I move 3, I'm at 53. And let's go the other direction as well. So 49, 48, 47. Now our sample mean was 47, which is right here. Now, how many standard errors below the mean is this? It's 3 standard errors below the mean. What does that mean? Well, below the claimed mean, since we assumed that it was correct. Since it's 3 standard errors below the claimed mean, this is an unusual event. Or it may be considered a very unusual event, but we'll just stick with an unusual event. Unusual event. And actually, if we worked it out using methods from Chapter 6, we would figure out that the probability that x bar is less than 47 is about 0.0013. So there's like a 0.1% chance that a sample would have a mean of 47. So what we can claim from that is, since there's such a low probability of that happening, we can say that the assumption that the manufacturer was correct, since it led us to an improbable result, we either had a very unusual sample or the ad is false. So, since the assumption that the manufacturer was correct, led us to an improbable result, because the probability was like 0.1%. Either we had a very unusual sample, or the ad is false. Which one do you think is probably likely? I'm going to guess that the ad is probably false. So what we do with hypothesis testing is we start with an assumption that something is true, and then we state an alternative assumption that the original assumption is false. And then we run tests and figure out probabilities and make a statement as to whether our original assumption is acceptable or not. So let's kind of get some vocabulary under our belts. The null hypothesis. That's the original assumption that we assume is true. And it is written H sub 0. H sub 0 is always the null hypothesis. And it is a statistical hypothesis that contains a statement of equality. So the examples, the types of statements of equality that we can have are greater than or equal to, less than or equal to, or equal to. The alternative hypothesis is H sub A. They're a little bit hard to tell apart, so make sure you get an O there and an A there. It's the complement of the null hypothesis. So whatever the null hypothesis is, the alternative hypothesis is everything else. The alternative hypothesis must be true if the null hypothesis is false. And alternative hypotheses always contain a statement of inequality. And they're consistent with the statements of equality here. So if the null hypothesis is greater than or equal to, the alternative hypothesis is everything else, which would be less than. If the null hypothesis is less than or equal to, the alternative hypothesis is greater than. And if the null hypothesis is equal to, the alternative hypothesis would be not equal to. Those are the only three options that we have available to us. So when we write H sub 0 and H sub A, we're going to translate the claim that's made about the population parameter from a verbal statement to a math statement. Okay, so let's go back to our car example. What was the manufacturer's claim? The manufacturer claimed that the car gets 50 miles per gallon. So we have to change that into a null hypothesis because it's the claim. The claim is always the null hypothesis. And they're saying the car gets 50 miles per gallon, not more than or less than. So the null hypothesis would be mu equals 50. Now, when the null hypothesis is mu equals 50, the alternative hypothesis has to be everything except for that. So that would be mu is not equal to 50. Now, we always want to note which one is the one that is claimed. So the claim by the manufacturer is that mu equals 50, which is our null hypothesis, and then our alternative hypothesis is mu is not equal to 50. So when you write the set of null hypotheses and alternative hypotheses, there are only really three sets of possibilities. The first set is what we just saw, where H sub 0 is that mu equals some number, and H sub A is that mu does not equal that number. Another possibility would be H sub 0 is that mu is less than or equal to some number. Then H sub A would be mu is greater than that number. The third possibility, the alternative hypothesis, would be mu is greater than or equal to some number. The alternative hypothesis that mu is less than that number. So let's talk about kind of what some words can be that would go with them, with each situation. So in words, it would say something like the mean is, and we're going to fill in the blank. So the mean is equal to some number, or the mean is not equal to some number. So this would go with the h sub 0, h sub k, h sub a would be that it's not equal to. Or if it said the mean is 73, like our problem said, the mean is 50. The car gets 50 miles per gallon. For the alternative hypothesis, it could say the mean is different from k. So any other thing, like the mean is not 72, the mean is not 50. Or it could say the mean is exactly k, or it could say, for not equal to, the mean is not k. If the alternative hypothesis is mu is less than or equal to k, you might see words like the mean is less than or equal to k. Or you might see at most k. Or you might see not more than k. Words for the alternative hypothesis would be greater than k, or above k, or more than k. For a null hypothesis that mu is greater than or equal to k, you might see words like the mean is greater than or equal to k. Or the mean is at least k. Or the mean is not less than k. The alternative hypothesis words would say things like the mean is less than k. Or the mean is below k. Or the mean is fewer than k or lower than k. We're going to look at some examples. We're going to do number 25, 26, and 27 on page 360. On number 25, what we're doing is we're going to write the claim as a mathematical statement. We're going to decide which one is h sub 0. We're going to decide which one is h sub a and state which one is the claim. So 25. A laptop manufacturer claims that the mean life of the battery for a certain model of laptop is more than 6 hours. So 25. What is being claimed? The mean is mu, and it says is more than 6 hours. So the claim is that the mean is greater than 6. Now we get to decide if that's h sub 0 or h sub a, and the way that we figure that out is by recalling that h sub 0 always has to have a statement of equality in it, and h sub a is always inequality. So since this one does not have an equality, it's going to be h sub a. So h sub a will be mu is greater than 6, and then h sub 0, the null hypothesis, is going to be everything else. So that will be that mu is less than or equal to 6. We also want to identify which of these two is the claim, and so we'll just write in parentheses next to h sub a that that was the claim for the problem. Number 26. As stated by a company's shipping department, the number of shipping errors per million shipments has a standard deviation that is less than 3. So we're switching parameters here. Now we have standard deviation, which is sigma, and it says is less than 3. So what's being claimed is sigma is less than 3. Now, will that be h sub 0 or h sub a? Remember that h sub 0 always has to have equality. Since this is not equality, we use it for h sub a. So sigma is less than 3, and I want to indicate that that's the claim. Then h sub 0 would be everything that's not less than 3, so that would be sigma is greater than or equal to 3. (27) The standard deviation of the base price of a certain type of all-terrain vehicles is no more than 320. So our claim is about standard deviation again. And if it's no more than $320, then that could mean that it's $320. It could be equal to that, or it can be less than that. So that's going to be less than or equal to. So let's do h sub 0 and h sub a. Remember, h sub 0 always has equality, and this statement has equality. So h sub 0 is going to be sigma is less than or equal to 320, and that's our claim. And then h sub a would be everything else, so sigma is greater than 320. I changed my mind, we're going to do one more. We're going to do number 30. Number 30. According to a recent survey, 39% of college students own a credit card. Okay, so that 39%, which parameter is that? It's a percent of our population. So remember, that goes with proportion. So it's a population proportion. And remember, the letter we use for that is P. So the claim in this problem is that P equals 0.39. H sub 0, H sub a. H sub 0 is always the one with the equal in it, so it's actually the claim of P equals 0.39. That's our claim. And the partner that goes with equal to for H sub a is not equal to. So our alternative hypothesis is P is not equal to 39.